My name is Alan Duboff. I work at Appcelerator, and I brought Chad Auld with me, who's over here, and he'll be showing some stuff on the phone or in the emulator up here. But so initially, I contacted you guys. I thought we had a pretty cool solution for Python programmers, because one thing is most of our back end is written in Python. So we create apps on the desktop, and we create native apps. They're cross-platform, and we basically run in JavaScript for the most part, or on the desktop they run in HTML. So basically, this first slide shows you what Titanium is and what we support. On the desktop, we support Mac, Windows, and Linux. And I'm pretty fond that we have a good Linux solution. Most all the stuff works on Linux. And I have one machine that I'm running, which I have connected, running some Python, getting some MySQL data, and I'll pull that up later. But the first thing I wanted to talk about a little bit, we're full open source. You can go get all the source code for our product. It's on GitHub, and there's some links at the end here where you can get that stuff at. Titanium provides a library that you can write it with frameworks which are accessible from JavaScript. So the theory is basically that these days a lot of people spend a lot of time writing web apps. They've invested a lot of time, and a lot of people writing Ajax and speeding their code up. And we do the same thing on the desktop. We allow you to do that, and we run WebKit on the back end. So basically, you have a web interface running on the desktop, and you run a desktop app which is running JavaScript, essentially. All of our libraries are JavaScript accessible, and then from inside the JavaScript code, you can extend it, and you can write Python, Ruby, or PHP. And Python is probably the best supported right now. One of the things is almost all the scripts on the back end that produce the applications are also written in Python. So a big chunk of our framework on the back end, which produces and puts these applications together, is written in Python. Some of the key points here for Python is that we have native applications running on your desktop. Standard web interface utilizes HTML and JavaScript on the desktop. On the mobile devices, basically leave you in JavaScript, and we use Squirrelfish on iPhone, and we use Rhino on the Android, which basically leave you in JavaScript. So one of the cool things is that Chad has put a wrapper around the Sculpt library, which allows you to access Python from JavaScript. So it's kind of cool, because now we have a solution both ways for you. And as Python programmers, you can write native applications in JavaScript that will run on the mobile devices. Mobile devices, of course, being a big thing now. And as I put here, we rely heavily on Python on the back end for manipulating and creating the applications. For Python developers, it's pretty cool. These are some of the stats. We've got about 21,000 apps out in the wild. There's 1.5 million active developers, and there's about 20 million active users, meaning people who are downloading and using the apps. So there's quite a number, quite numbers here of applications that are being developed. We have a lot of partners that we're involved with, doing some big applications, and there's some really cool stuff. Some I can't talk about because we're under NDA, but there's some really cool applications out there for not just mobile devices, but for tablets and on the desktop also. Yeah, well, it is using native apps, and they're running basically in JavaScript, and basically programming in JavaScript WebKit is used on desktop for some of the controls. The frameworks that we have provide windowing. You can create processes and threads. You have management of all your processes and threads. We're full open source, and we use open source products mixed in with our stuff. So we have third-party open source. We support desktop, mobile. Our studio developer, everything is all open source. Most of our stuff is licensed under Apache, and it varies for the products, but we do most of our licensing under Apache. You can download from GitHub. If you use GitHub, you can go get most of the code. All of the studios out there, developers out there, Titanium Desktop, Titanium Mobile, everything is available out there as open source, and you can go clone it. So what's actually happening behind the scenes? So let's talk about desktop. On desktop, I mentioned that we're using WebKit behind the scenes on the back end. So essentially what you end up with is having a web interface running on your desktop, and we leave you starting with an index.html, which would be normally how you would code if you were coding on the web. So essentially what we do is we bring the web interface onto your desktop. There's no real magic about it, since we just use WebKit for that. But most of the programming is done in HTML and JavaScript, as most people would do on the web. The difference is you don't need to have a server running, and the applications essentially run on your desktop as they would be running on a server normally. But you don't need to hook up with a browser and such. So it's kind of a cool environment, for anyone who hasn't coded in that environment before. It's very natural for people who have written applications running on web servers using HTML and JavaScript. And so, of course, these days, most people are doing that. So this fits right in with most people's work, and a lot of people have JavaScript libraries that they've written, either Ajax or whatever. They can integrate them in very easily in this, and or use other JavaScript libraries that are available, like jQuery and such. And then we reduce the application development time drastically from what you would normally spend writing applications in Xcode, for instance, if you were targeting the iPhone or the Android. But we have a very similar API that we use for Android. You essentially program in Dalvik, and or if you wanted to extend it, or you would be in JavaScript writing your code, and you would write that way. We have a bunch of examples. One of the nice examples that we have is a Twitter client that's called Tweetanium, and it's in the Apple App Store. It's also available on GitHub, and Chad ported the desktop version. And that's all done in JavaScript. So this is an application that's written completely in Titanium. Chad wrote this in about 2 weeks. I have it set up as my Twitter client. He could probably show you a lot more than I could on it, but all the source code is available. It's in JavaScript. So here's an example of how we would call JavaScript. We have a TI include function that would call a Python script, and then that would get executed in Python. The namespaces get extended so that while you're in Python, you can access your DOM elements and such, which is nice. And as I mentioned before, Chad wrote a glue layer around Sculpt, so it allows you to access Python from the JavaScript as well. So it's a pretty powerful environment. And that's, that would be essentially how you would start your application from an index.html, and then this is an example of calling MySQL from there. The difficulty in that is that you need the stack all lined up, which is actually ironic. It's easier to set up on Linux, for me anyways. because you can apt-get most everything, and everything's compiled 32-bit or 64-bit. So, but it's tricky to get the stack set up all the way down into MySQL, because on OS X, for instance, they have a 64-bit Python, and even if you tell it you want to run 32-bit, you can go check and it'll give you a 32-bit int size if you do sys maxint, but it's still running in 64-bit if you look in the active monitor. So they kind of trick you out. It's, not sure what the advantages of that, but like I said, I found it easier on Linux to set up the stack and to run the MySQL, so I brought a Linux machine with me. And I think it's good, that we support Linux, and Linux pretty much runs the same as the Mac and the Windows versions do. Yeah, he was asking if you could bundle a specific version of Python with the application. And in the case of Python and Ruby and PHP, we include those in as third-party. So yes, I mean you could replace it and put your own Python if you had a specific version of Python that you wanted to use. You could do that also. And once you create an application, you can modify your project and tailor it, and everything that's in the project will be created and taken into that particular bundle. Another thing that we do that's kind of nice is you can do your development on one platform, and you can package for all 3 platforms on desktop. So as I mentioned, we support Windows, Linux, and OS X. You could compile for all of those from one set off whatever platform you're developing off, and it'll go off into our cloud and produce packaging links back to that. So that's kind of nice also. You could also distribute that way and use those links as your distribution if you want it. So that makes that nice. Let's go back here. And basically I was explaining like what happens behind the scenes. Most all of the libraries are written in C++ or Objective-C. We maintain all 3 platforms, so there's no magic there. We have basically 3 sets of code on desktop. Some of it's reused, but a lot of it has to be separated because of the Objective-C or C++. We use GTK extensions on the Linux side, and we use the Cairo extensions in the WebKit on the Windows side. So, but they essentially all have WebKit running on the back end, which allows you to get your HTML interface. In the future, the way we look at it is we have basically an engine that we want to just plug in different engines. So in theory, if you had a Java app, we could do the same thing with Tomcat or JBoss and run that on your desktop. I don't know if there would be that much advantage to doing that. You could run Java apps on your desktop for the most part anyways. So, but in the sense of thinking of engines, I like to think of it as just plugging in an engine. As an example, we could plug in V8 and have a JavaScript only engine on the back end, or just use Squirrelfish and not take in the HTML portion of the WebKit. So there's a lot of different things that can be done there. We have a full set of APIs in Titanium. You can get geolocation. We have SQLite that's embedded in it, so you can save your information with SQLite. If you need bigger stuff, you can go into either Python or Ruby and get to MySQL. We're thinking about writing a database module in the future, but most of them, you could write modules that could be extended also into the frameworks. So it was designed from the ground up to be able to extend like that. We have, various different interfaces, and we have libraries that will let you get to Facebook. You could get to Twitter easily. So a lot of the social networking, file system, sound, video, all types of multimedia networking. So maybe this would be a good point here for Python developers, where Chad has wrapped around the Sculpt library. I happen to think that's really cool because that allows and extends Python to allow you to write on mobile devices. Mobile devices, of course, are very popular now. People scrambling, trying to get mobile applications. There's not a lot of people that are doing the kind of applications that we're doing, so that space is really, it's not abundant with development environments yet. And I would say we're one of the first. There's a couple others out there, but it seems that we're one of the more mature ones. And we've been around for, I don't know, like 4 or 5 years. I think desktop's been around and mobile's been out there, and there's some big partners working with us. So maybe at this point would be good to, you want to come up and talk about the Sculpt stuff a little bit?
This was just an idea that we had, maybe a month and a half back. It was just, I really like the idea that you can do Python development in our product on the desktop, or PHP or Ruby. So, most of the apps today that we build are built in JavaScript for the mobile devices, and I really thought, well, is there a way we could do Python on the mobile device? And so I started kind of playing around trying to come up with an idea for this. And I don't know if everybody's familiar with Sculpt, but let me see if I can pull it up here. I stumbled on this one, I don't know, maybe a year back or something, kind of bookmarked it and kept it in my brain, but didn't really do much with it until now. But essentially, someone has built an entire, basically built an in-browser implementation of Python. It's not fully complete, but it works pretty well. And they continue to improve it. So my thought was, could we take this, essentially JavaScript library, embed it into the phone, and then make it accessible through our product, right? And so, this is running in the browser, but you can see, I think it's Control-Enter. Let me scroll down a little bit. But you can see that it's actually, here's the Python code in the upper window, and it actually executes this out in the browser. So you can write real Python and get the results within the browser. So what I did is actually take this library and embed it into, we have a module platform, which allows you to take, you can write applications, say you have a JavaScript app and you want to be able to do native stuff on the phone, in Objective-C or in Java if you're on Android. You can extend the platform, write your own module in the native language, and then use JavaScript to access your own module. So maybe there's a feature on the phone that you want that we haven't built into our API yet. You could write that feature in the native language on the device, access it through JavaScript, right? You can also, if you don't want to do a native either Objective-C or a Java module, you can write a pure JavaScript module, which obviously you could write once and then reuse on both platforms, right? So I took this, used it as a pure JavaScript module, and then injected it back inside our own namespace. And so you can access all the functions of Sculpt from within Titanium. So let me show sort of an example of how this actually looks.
There's a simulator running there also.
Yeah, I wanted to dive into the code for a second. So let me scroll this guy down. You see that? I can make it a little bigger. Big enough. Okay. So you can ignore the top part. Basically, at the top, I'm including the module that I've written, the pure JavaScript module. The cool stuff is actually in here. So basically, I'm just showing off that I'm calling through the TI namespace. So I'm calling TI Python, and then I'm calling into standard functions like min, max, absolute value, and I'll show you like the result of this as I go through it. We also have this, so you have the functions available to you, so you can just do basic function calls, and that's pretty nice. But really, what I wanted was to be able to do like real Python, and so I created this helper function that exposes some of the stuff inside Sculpt, and it's actually called execute into variable. So here's where you can write inline Python, and you can give it a function that you want to render it back into. So in this case, it actually runs, assigns 5 to A and 10 to B, and then it actually runs a range on A and B and assigns it back into the variable R, which ultimately gets reset back into new range. So it's now a JavaScript object that contains the result of inline Python. Does that make sense? Okay. And to go a little bit further with that, you can actually, I wanted to be able to take a pre-existing Python code, have it in a separate file, and be able to actually use it from within JavaScript. So if I took a very basic class, there you go. So I have a class Fun with Math. Has two methods in it, right? One add values, one subtract. And then the only thing that I'm doing in here that's not inside the JavaScript itself is I'm actually pre-creating an instance of this class, right? And now that I do this inside the JavaScript code, I read in the file, the Python file, and then I actually call this sculpt function called setModule. So we read in the pure Python, we pass it in, we set it as the module that we want to interact with from within JavaScript, and then we can actually call methods on it using this helper that I wrote called execute module function. So you pass it the instance that you want to work with, you tell it the method that you want to interact with, and then you can pass in whatever parameters that method normally takes. And it'll render back the result and put it back into JavaScript for you. Oh yeah, he asked if I actually try to do anything like a proxy class or something. I have not at this point. Like I said, so it's an experiment. I've written a demo app, all the code's out, it's open source, so I'll probably keep playing with it, but I hope other people will as well, right? And just that it, give some feedback from the community on it. So in iPhone, it's actually really fast. On Android, if you try to run it in the emulator, it depends. We had trouble getting on Alan's emulator earlier. On the iPhone, I'll show you when we launch it up in the simulator. It's actually really fast. I haven't done anything to really stress test performance, so I can't say what it would be like in a real application at this point. But as far as this simple test that I did here, right, it just does some min and some max. It does a range. It reads in the class, and then it calls a couple methods. Let me show you. So you see once it launches, it's pretty much instant. Right?
What's Sculpt written in?
It's all JavaScript at the end of the day. I mean, it's compressed and minified and all that good stuff, but it's not Bitcode. But when we recompile our stuff, all the Javas. So in our stack, when we actually compile the project, all the JavaScript gets compiled down to Bitcode, and then and as I was saying earlier, we have a JavaScript binding layer, so we bind everything to that. In this case, you're not binding to the UI directly in anything that I'm doing, but you could bind your code directly to like UI elements and stuff. So, I mean, it's going to be as optimized as it can get from a JavaScript perspective, but it is somewhat heavy. Yeah, another idea I had along the way, which I never really got around to, is I don't know if you guys are familiar with mscripton. So this is, have you seen this before? LLVM to JavaScript, and so I've heard of people taking CPython, converting it 100% to JavaScript. So the theory would be, could you take that then and embed all of CPython into Titanium? Of course, the file that it outputs is a fairly large file, so to include that on a small mobile device, probably not that performant, but theoretically possible and maybe fun to play with. Okay, so yeah, so this is running on the phone. Basically, I'm just echoing out the what I went through before, but you can see it running, min and the max, the absolute values. Here's the inline Python code. You can see the result, and then this was the class that I interacted with, and you can see that it's actually returning the right results. So it does work on Android. It does work on iPhone, and there are custom modules that you can build for each platform to do it, or you could just take the JavaScript itself and include it directly into the mobile project. So
Should work on iPad also, right?
yeah, iPad should be fine.
So yeah, it is true that there are cases where it will be slower, but I still think it's very cool that you can access and write from JavaScript with Python on the phone, on a mobile device in JavaScript. Pretty cool. Yes, through the App Store. There are Titanium apps in the App Store. Yeah. And it works differently on the phones than it does on desktop. But we also have apps that are on the App Store. Well, we have one app on there. The Tweetanium app that Chad wrote for desktop is in the App Store. If you're familiar with doing any of the app development for Apple, everything needs to be signed with a certificate. Pretty much if you use our SDK to write the applications, it eliminates a lot of the low-level Xcode work that you would need to do. We do a lot of it behind the scenes for you, but you don't need to mess with that. But you still need to be a developer and have all the certificates in place and sign the application, and the application needs to comply. If you've looked at the Apple site, they have a lot of, quite an extensive laundry list of things that you are or not allowed to have in your application on the App Store. Now, on desktop apps, it's a little bit different as well, but they also have a long laundry list of things that you're allowed or not allowed to do. And here we are. It's been 5 years since they discontinued the PowerPC chip, which is, for a lot of us, it seems like yesterday. And already Apple's not supporting PowerPC. You're not allowed to have any PowerPC in the universal binaries if you submit to the Mac App Store. So we had to pull all of that out of our libraries, and we have two different sets of libraries. If you want to compile for the App Store, we basically do a soft link against the system WebKit, and it brings the size way down, where an application is only a few megabytes. So when you talk about having an application that's, dragging in like 50 gigabytes or whatever, that's not really the case here. And in fact, the apps are very small if you do it that way. Like I said, Tweetanium is only a few megabytes, and you can go get it from the App Store. It's free. You can go get it from the App Store, and the JavaScript code is there, but you can go get it. You can download it from Git also and look at it. So it's all minified on there, so it's harder to read the code that's in the App Store. But essentially, you can write applications for the iPhone or the Android, and using our SDK eliminates a lot of the low-level work. This is basically showing extending Python from a Titanium application from the index.html. And you can see that what I've done here is very simple. I've created a JavaScript function that is called useMyPythonData. I'm going out and I'm including a test.py, which is going to pass to the Python interpreter engine, and inside, for instance, from inside of the test.py, we can access our DOM elements, and we can get a prompt and query, which is kind of cool. You could also use any of the Python interfaces and classes inside there, of course, as well. In this particular case, I'm just doing a simple prompt. And the test case, I have a test case that basically goes out to the file system and does some queries for files. So it prompts you and asks you for a mask that you would like to search from a given directory. And then it goes off and gets the files, puts together a bunch of text, passes it back up through to the JavaScript, and then just uses window alert to display the text. Okay? But the cool thing is that it shows that you can go down into Python and back into the JavaScript. And then I also have one example on Linux here, which I was going to show, which goes down into Python, uses the MySQL DB connector, queries the database from the local system. I just have a small database with a single table in it called users. I get the first and last name of the users, pass it back up the same way to the JavaScript so that the data is available in your JavaScript. So you have basically both ways. You can, you have your JavaScript and you have your Python, and you can call the DOM elements from your Python, as well as sending your data back up to your JavaScript and creating events up there as well. And you have full access to the Titanium libraries also, which have full UI and everything on them. But of course, the Python stuff is just pure Python files that get executed and called and passed through to the Python engine. This was showing the Sculpt functions here, accessing from JavaScript. And here's a bunch of links that I have. What I'd like to do now is show the, well, there's a couple things. There's this link right here with the kitchen sink. You can get that from Git, and that shows on the mobile side, you can run it through the simulator or the emulator. They have a simulator on iOS. They have an emulator for Android. You can go download them for free and run the kitchen sink in either one of those. Those show all the basic controls and such that you can access through the Titanium frameworks. So you have sliders and etc. So this application here is the one that I was just talking about that goes down into Python. This is a simple piece that calls test.py. Here's test.py. It basically prompts you for a file mask, goes out into a given directory that I have set here. And it's basically, I was setting up to use Google Closure. If you're not familiar with Google Closure, in our last SDK we included Google Closure, which is basically obfuscation for JavaScript. And so this was basically when I was testing to get it working. So basically I put together a bunch of stuff that I was send off to Closure, and I just pass that data back up to the JavaScript. And down here you can see I'm using use my Python data is passing it back up to the JavaScript, to the function in the JavaScript. So if I run this, for some reason we lost focus here. So it's asking, I'm just going to leave it, it defaults to JavaScript files. Okay. And basically, now here it's back displaying it from the JavaScript side in a window alert. And I'm just, for each one of the JavaScript files, it's just passing data back. But this shows basically how you can interact with Python and pass it off to the Python engine, get your data back, it loops through and then just sends it done. Yeah, well, JavaScript doesn't have types really, so, you can pass any kind of data you want it, as long as you know what to do with it. You could put it together in arrays, and you could access it from there. You could pass them back separately. You could set up different functions to do that in your JavaScript and as such. I think technically we have one main thread running to run the JavaScript, and then there would be another thread that kicks off the Python. You could create threads and everything through the Titanium library. So you can actually create objects and methods and kick off, for instance, run a method on a thread and extend it that way. So you're not restricted to running on one thread per se, but one thread is running for the main process. Yeah, when you mentioned process, I just wanted to be clear about that. You could create new processes and threads on your own so that you wouldn't be limited to having them all on the same process. And one of the things that actually might be good to show is in Studio, if I launch the kitchen sink. The kitchen sink basically shows a lot of the controls. If you go git clone it, you can run it in the simulator. So basically, here's different kinds of sliders that you can program in. You can hide them. Shows your toggle, slider and toolbar. These are most of the basic controls. Activity indicator. Send a message to it. Put it in the toolbar. Nav bar. Indicator title. Show basic. Progress bar. Different buttons. Labels. Search bar, give you focus, keyboard comes up. We support different paradigms on we support the gestures that are on the tablets, iPad, or we also support the Galaxy or the other Android. We have a Zoom also in-house. We have a few of the different tablets though, but the iPad 2 and the iPad 1 are supported.